So you all saw this morning where Marty showed off the haptic feedback system. So I think we're going to take this opportunity to kind of pass around some of the haptics right now. And then we're going to get into actually the design flow that we get. So with our process that we're using, we kind of have to create a tailored solution that fits really form to the arm because we're doing a myoelectric prosthesis here. And so in order to do that, we have to integrate a 3D printed scan, or 3D scan to get to the printed stage. And so what we've decided we're going to do is show you kind of how we get there. And so again, with Marty, he's going to pull up his computer, and with the sensor in, he's going to do a scan. And once he does the scan, he's going to put it into software, which I'll watch him, and he's going to make me a socket. So this will be fun.
We're going to build a socket right now. Alright. So here we go. Connect software. It comes with. Okay, there we go. This Connect software comes with our scanner.
There we go.
Alright. So let's try. Let's go with body. So 0.6 meters will be how far away it would need to be from the object. So in this case is Chad's arm, and let's start.
Is it, actually, do we want to have someone do the scan? Does someone
want
want
to
to
try
scan?
this out? No.
No?
No one wants to.
You want to try? Come on down.
So
Thank you. Alrighty.
here are the instructions.
Okay.
Let's get this up and open.
The bounding box is basically a box around the object that you want. So it needs to stay a certain distance away where it's green.
Okay.
You can see here. So if it's too close, it's going to be red. If it's too far, it's going to be blue.
Okay.
So try to keep it green.
Where's
and,
yellow?
bad.
The goal is green. Okay.
So green. Green is what you want. And if you move, it's basically a circle around the object. So when you move, you want to make sure it's about the same distance away.
Okay.
And this is pointing directly perpendicular to the object. So if you try to move around like this, you can see. Yep. Yeah.
And so, do you want me to stick my arm in the air?
I think your arm here is probably fine.
Okay.
So make sure
yeah.
that it's pointed perpendicular to it, and see it's a little close.
I see.
So this is why we need the rig. So it's
Right,
very,
so that
very,
it's even, right?
Yeah.
So when it's too far away, what do we do? We decrease the box
You
size.
could take it from here to here, hand it to me, and I'll take it from
Sure.
there.
Yeah.
But make sure it's green. That's all you need.
You can decrease the
means
size
go.
too.
Decrease the size.
Keep this in this.
Let me see. You want to decrease the size of the box? I don't think that'll help. Let's see. How is that? About the same. Okay. So you guys just ready to start? Try it out?
Sure. What is the pixelated? What's
This?
that's okay?
Yeah. Oh, that's good. Yeah. You just want it to be green is all. Alright, ready?
Okay.
So move her whichever way you want. When it starts.
Oh, sorry.
It's all good. There you go.
Doing great.
And you want to be a little slow, not too fast.
So
And make sure this is in the center of the screen as well.
So yeah, this is where you have to kind of get on the ground sometimes. And I think Jeremy had a great suggestion when you're doing these scans. It's really simple if you just stick your arm vertically in the air. So you don't have to kind of get on the ground and worry about, losing the image or maintaining that.
Go ahead and grab it. Yep. Make sure it stays in the frame. There you
You
go.
need cord there.
Oh.
Another limitation is in this method, you're only bound to the distance of the cord. So in the other methodology of scanning, you can use the iPad scanner directly with the program built into the iPad, and it creates the STL image that you can export to edit.
do you want me to take it?
Yeah, go ahead.
You got it?
Yeah.
Oh, slowly. There we go.
All right, I think
Should be
we are.
20-something, but 22.
All right, I'm gonna stop it here. I think it got everything. So it might not be too great because sometimes the distance around the arm is moving around a little bit. So let's see what we got.
So when we were doing this on the iPad and streaming it into the software on the computer, it would take about 5 to 10 minutes for it to process the image. But with the dongle, it just simply puts it all together and you can move into pre-processing.
So it's actually really good.
Right.
Wow,
Yeah,
that's
so we just missed the tip, but that's, that's okay.
that's a lot better than I thought. Okay, so as you can see, the tip here is missing, and that's okay. We can fix that in post-processing as well. So once you have the scan, this you can export this into STL. But let's take care of this stuff first. Let's go to process. Let's go to move and crop. And crop out all that stuff. You can do this in Meshmixer as well.
So while he's putting that together, I'm going to pass around some of the pieces we've made from this scan process. So we actually have the flexible material for the outside. It's now printed flat. And then we also have the distal head, which is printed in nylon, correct?
Yes.
Yeah. So I'll pass
It's a
this one
special
over.
nylon. If you want to know what type it is, it's a special nylon called PCTPE from Tallman. It is a lot more flexible than normal nylon and still retaining its layer bonding qualities.
And standard FDM printers can handle this.
Yes, both of those.
Everything
Yeah.
was printed on FDM, right?
Mhm.
Yep.
We printed it on an Ultimaker, both those parts. So now we're trying to export this. We are trying to export into STL. And let's export this. I'm just gonna put it on the desktop and name it Chad's Arm. So now we go into Meshmixer.
Who's used Meshmixer before? Raise your hands. Okay, good.
Awesome. Oh, you guys remember how to do
Excellent.
this, right?
But it's as if it's brand new every time.
Here we
It
go.
can feel like that.
My bad. Import is what I meant to do. You can import this file into here. And now we're going to try to fix the problem. Why is that there? That's very interesting.
Remarkably good scan.
It's really, really good. I can't see it from here.
Now, one thing we're interested in is how good is the accuracy on these scans? So one idea that we were thinking about doing in upcoming clinical studies is to actually measure the moles in the CAD that we create versus the actual physical measurement. Very similar to how the FDA was doing simulation testing and actual testing. You saw in the image that FDA provided this morning, the image of that acetabulum of the hip, where you saw a traceable line of the image, but also the actual line, and there was significant deviation.
Marty, you need to explain what
I know.
you do.
Chad was talking. Sorry.
No, it's okay.
I'm a nerd, I'm sorry.
So in order to fill this hole, any blue line you see in Meshmixer is a boundary line. That means it's open. That means, we all know what a mesh is, right?
Yeah.
Yeah. Well,
Who
I guess
doesn't
not.
know?
Sorry, that's what I meant. Does anybody not know what a mesh is?
Explain it.
A mesh is basically a surface, a zero thickness surface, and it could be in triangles, it could be in rectangles. So here we have triangle meshes, and the meshes need to be bound together for it to be a full solid body. Here, this is open. That means this is not a solid body. This is a zero thickness shell, basically. So we need to close this. In Meshmixer, if you see a boundary, you can double click near the boundary and it will select that boundary by itself. You can expand it a little bit by controlling and scrolling on the wheel. There is an option called join. Just kidding. Trouble?
But it knew you were kidding.
How interesting. Let me... So this, I guess this is where Meshmixer sometimes has problems. You just gotta troubleshoot a lot of it. Let me see if I can do something here.
What are you doing?
I'm trying to troubleshoot here.
Join and close.
So in order to close this, there's a lot of tools in Meshmixer. Right now I'm using the sculpt tool.
Thank you. And
So
you're set to what?
I'm setting it to robust smooth. So there's a lot of options. Here are the brushes. There's drag. There's drag, which you can drag the meshes around. You can pull it outwards. You can pull it wherever you want. There's draw, which just expands it out in the direction that you want. And these two are very similar, but I probably don't have time to go over that much. But
If I may, for people who are trying to get used to Meshmixer, I never get used to Meshmixer. The menu structure is quite puzzling, but you can do almost anything with it.
And
So,
YouTube is your friend.
watching what is your
Dr.
friend?
YouTube.
is your friend.
YouTube.
Your friend.
I learned everything from YouTube.
This very video will be on YouTube, so,
So you're basically going to push mesh around here close.
Yes.
so he's smoothing it up.
So, Meshmixer is very finicky, and sometimes it just doesn't like certain shapes, and it won't do things that you want it to do. So let me see. I'm trying to smooth that that boundary, and see if it can let me
Yeah, and I
do
think
what
for
I
your
need
purpose,
to.
you're just creating a socket of the upper arm. So in this case, it's negligible as far as the anatomical changes to the model. But if you were considering doing something for that distal anatomy that's missing, you may want to consider rescanning or even trying to get a more robust scan for that.
Are you stuck? You scratch your head, what will you do with the station?
So it's not letting.
Make it a showy.
Okay, tell people in TV land what you're doing.
I am trying to troubleshoot. So I guess if it doesn't close, we can always make it into a solid. Let me see how it goes.
Question.
Yes.
So I've never used these before, so I'm very curious. You said you just rescan. Could you just rescan the part that you missed and compile those scans together, or is it not as well calibrated to allow that?
If you have good practice and you are an artist, by all means go for it. But that is very technically challenging.
So it's just easier to take just a whole new scan.
Yeah, the simplicity of it, definitely makes it easier just to do it.
Draw faces between vertices.
Right, can you show us what you just did while
So-
I was talking?
This was a good trick.
Here's the hole, right? And right now it's a surface that there's no thickness, and I just use the Make Solid tool. It'll try to fill the holes and connect everything together to make it a solid body. So that means this hole is filled, and this hole is filled, and now there's actually nothing in there, but it's a solid bound body, so there's no way to get inside is basically what it did.
It's a closed
Good
shell.
news.
It's all
And
closed.
And you need a complete mesh like that if you're gonna print.
Yes, you do.
Yeah, which we do print out the models. Yeah.
So right now, the reason we're trying to fill this is because we need to make a socket, and we're trying to offset from this scan, and if there's a hole, then it's going to be a problem. So now that it's a solid body, this is where your artistic skills come in. You can literally just draw whatever you want. This is how I design that particular shape. I can draw like this, and I can offset this from the socket. So this is very customized to Chad's particular arm. Say you just want a socket. You can, that's inverse selected.
So what are you doing there?
What was that maneuver?
So this, I don't know, I'm not exactly too sure how this works. So it's inversely selected. Let me see, I can
It's kind of
invert
like
it,
a
I guess.
select all
There you
tool.
go.
Instead of painting it on, it's kind of a select all.
What tool was active?
There is no tool. So let me go to nothing.
Start over, go slower.
Select, yes. You can just click outside of the scan, drag it across, and it will select one of the sides. I never know which side it will choose. So if it selects the wrong side, just go to modify.
You selected the wrong side, and then you're saying swap it.
Yes. Click invert. It's basically like Photoshop. So now it's inverted. Now it has the selection that we want. And then the goal is to offset this, right? If we click offset, it will offset the surface away from the scan. And I have it at 0 right now. Let's say 2.5, which is a good number that I usually use.
So that's the distance from the actual body you want to offset from.
So you're making a skin, an external skin layer.
Including
2.5
2.5 millimeters outside.
Yes.
So it would be a 2.5 millimeter clearance between the object and your skin if you tried it
Now,
off.
why would we want to have a depth there?
Because you don't want to just have a simple print on top of your skin. You want padding. You want to accommodate for that. No matter how thick it is, I feel like 2.5 millimeters is pretty good.
So this offset, you're basically defining the lower surface, the surface that's closest to his arm, and then
Mhm.
I guess the next step would be to set the thickness of this.
So the process of doing this whole thing, because there's a lot of things that we need to do before we can do all these steps. The steps are get the scan, fix the scan, offset this single surface away from the scan, so we have one surface, offset it again to the thickness that you want it to, and then there's an option when you offset to connect the two surfaces, so it become an actual thickness. And then when it's connected, you have technically the socket, but it apparently
Set
doesn't
the
like it.
resolution a little high.
No.
So the 2.5 is
Don't we
for
go by
padding.
margins, right?
2.5 for the padding.
2.5, the 2.5 millimeters is so that we can insert padding where it's comfortable for the user.
Yep. But it's taking a
Okay,
while.
so 2.5 is your padding allowance.
I feel like that's pretty good for any
It
padding.
depends on also what grade of padding you're using. That's where the user intuitiveness comes in. So for myself, I like having moleskin at the distal tip, so it allows me to have less of that pushing on my appendage, but I have the comfort on the upper arm where it's kind of bearing a lot more of the weight as it's being distributed up my arm. So I feel like it's a lot more comfortable having more than one modality of foam in that case. You broke it.
So whenever this happens, what I like to do
So
is stop it.
So what happened,
It-
Marty?
So it's solving. It's not solving.
So what does it mean by solving? What's it trying to do right now?
It's trying to calculate the offset and trying to render an offset, but it's apparently not. So I'm gonna force quit that.
Oh, it says math.
So the program crashed.
It didn't crash yet, but I know it's not gonna go anywhere. So
It's stuck.
we're gonna restart. Whenever this happens, okay, do not reopen the file. Close the program, click open Meshmixer, but don't open the file. And it will prompt you with Meshmixer recently crashed. Would you like to restore? Yes, restore, and it'll give you back your file. If it's not saved, don't worry, because it's automatically saved. So let's try that again.
Decrease the resolution. So you're gonna create the boundary, you're gonna invert it, so now it's got the full arm.
So you basically you're slicing it, and then you can pick which half of the slice you want.
Precisely.
Okay, got it.
Let me see if it works now. Sometimes it does, sometimes it doesn't.
Reduce that.
There's no, that shouldn't be a problem. This never happens to me. I don't know if it's good
Tell
enough.
me, my computer was slow.
Huh?
Is it actually looking for a surface?
Yeah, we selected a surface, so it's trying to offset that selected orange part away.
But you convert it into a solid, right?
Away,
But if
away
you-
from what?
Huh?
From its existing surface? So it's trying to draw the part you selected, the piece in orange. It's now trying to replicate that 2.5 millimeters larger.
Yes.
Well, total, it's out.
Mm-hmm.
And render the whole thing again, so it'll be like, and then it'll overlay it, and it'll
So,
appear to be overlaid.
so what we do when it's fully
It's
solved,
moving.
It's going, it's
you'll
going.
do the initial offset to create that gap, but then you can offset it and tell it to join that offset with the previous one. So that's where you can create the thickness of whatever socket you're putting on.
Got it.
I wonder if I should just open up my
Close
old.
MATLAB.
I'm working on MATLAB. Fine, I'll close MATLAB.
Do you find this is easier on Meshmixer, or would it be easier on like a commercial software like SolidWorks?
So here's the thing about SolidWorks. It's very good. Oh, it crashed. That's why. SolidWorks is very good at creating geometric shapes like gears, cubes, anything like that. But with an arm, it's very organic, and it's very different with everybody. So it's going to be very hard to make something like
There
that.
are some good videos. Ben Ryan, Paul Soki, Autodesk. They've established great videos, workflows from creating an OBJ file. There we go. OBJ file, and what's converting it from a triangular mesh to a quad mesh. So the quad mesh, you get 90-degree angles and lines, that are parallel to one another, and then you do these T-splines where you pull it over and you're actually creating the object in SolidWorks as a solid piece. So that's how you would go from this into SolidWorks.
You can work with surfaces in SolidWorks.
Mhm.
It's just hard.
Yeah, yeah.
So this isn't exactly surfaces, this is more of a mesh. For surfaces, it's a little different. The surfaces in SolidWorks, for you to make a shape like this, you have to use a bunch of splines, you have to do a bunch of 3D
Right.
sketches, and I've tried it, and it's, You know what? Let me redo this. Let me just do offset, basically a offset of your wrist portion. How's that? I did. I closed my web. Sorry, I'm working in the background. I have homework too. I'm a student, okay?
He's a good
Do
student.
you have other programs in the background there, working?
Several.
Oh, that's what's happening.
Yeah.
Several. But I've done it a bunch of times. I've done it a bunch of times. I should be okay. Let's select this part this time. Oh, I selected the right part. Let's select this part this time. What I want to show you is, let's say 2.5.
I think I see smoke coming from
Purring.
Hijack the computer and just mining Bitcoin.
I guess this just doesn't like me one up.
I
Here.
think, yeah, oh, there we go, it moved. It moved. It moved.
So yes, if you have a computer with better graphics card, definitely use it.
And that's good for any CAD
How much
software
RAM do you
in
have?
general.
Huh?
How much RAM do you have? 16?
I think 16, might be 8.
What if you
16.
lowered that accuracy slider all the way down?
Yeah,
Would that speed
16.
it up?
That's what I was saying. So you can play with some of these tools to make it less or more resolute or accurate to the image. So I
You also
know
close the other 4 programs running.
I tried that first.
I can't close everything, man.
We'll write you a note to your professor.
Actually, he needs one.
We'll send
I
them
definitely need
video.
one because I have a project that was due yesterday. Alright, you know what? I'm going to use the old one. How's that?
That's fine. Just build from the old.
So this will be a different scan, but it's basically the same thing.
Same arm. Same arm, different scan.
Probably had it lower resolution.
Yeah.
That too, when you have the STL file, if you can get away with a lower size, it definitely will play into that.
So the resolution means there's you couldn't see it, but there's a lot of tiny triangles on there. Low resolution means it's going to be bigger triangles and lesser.
Less accurate.
Lesser? Sorry. Less triangles and bigger triangles. Okay, so this is the file from which I made that socket.
Cool.
I'm going to hide all this stuff so we can see the original scan.
So what's that right there that you have?
This is the object browser. This is very, very important. You can select different things that you've made. So if I can get it, I can't see from here. From here, you can open the object browser by going to View and clicking Show. Showed object browser. This says hide because I have it.
Yeah, so when you're working with very complex models with lots of work into it, it's good having this object browser so you can kind of go to each of those workflows. Again, back to that process control.
So you think the object browser is actually showing the stages in the evolution of the object on the screen?
So, so if I just pick one, these are different objects that I've created before, and I just haven't had time to delete them. This is one of the prototypes. This is one of the other prototypes.
So yes, that is like a way of doing our process control. You're having each of the iterations in this browser.
Here's the thing about Meshmixer. Once you do something, it won't. Oh wow! Once you do something, it won't let you undo it. As in, once you save it, you can't undo it. So you have to save a bunch of different iterations. Is what I'm saying. Once you say you modify it's not like SolidWorks.
So how
right?
do you put a state into the object browser?
You can't. You have to save as a separate file. So you can go back to this file to edit it.
There's no history feature.
No.
So it's not a history, all right.
There's no history. Like SolidWorks, there would be
No, I get it.
separate
I get
things,
Just the way
right?
he's documenting it, it kind of shows his progress for his own intuitive purpose. But yeah, there's no trackability in that. function.
All right, I've only got a few minutes. Let me see. Where's that good one? Let's go with this. Oh, that's not the good. Okay. Let's say it offset it correctly. This will be the correct offset, right? This purple shell is the offset. Let's say it did correctly offset. Now you need to offset it again. Select all, which would be Control A, or double click on the purple surface. Then you need to offset again to create that thickness. But I don't know how well. Oh, it did really well this time. Let me see.
And as it happens, you're doing 2.5 again.
Yes.
Fair, okay.
So you will
There
see,
it is.
sometimes you'll see these weird jagged edges, right? These weird jagged edges, they are, there's ways to fix them.
Socket.
So for this second offset, you want to make sure that you click connected. That will connect these two surfaces together when you offset. So you click accept. Now you have a closed surface. Now you clear selection so it's not selected anymore. You have this socket here now. You can hide your original scan to not see it anymore. Now you have this socket. Now there's a lot of different options of fixing and making it look better.
So what are you using?
I'm selecting this surface right here. Any difference in color you see, you can double click to select it. So if you want, say you want to select just this edge right here, this green edge, you don't have to go around and select it. You can just double click on it. If it doesn't, you can double click. Meshmixer doesn't like me. Double click and it'll select this green section. Press Control and scroll on your wheel, and it will expand that selection a little bit. And let's say we want to smooth it out so there's no jagged edges. You can go to Deform, go to Smooth, and it will smooth it out. And you'll see there's still a little bit. That's okay.
So you can change with the smoothing tool,
You
the
can
level.
change smoothing scale, but
Those are just calculation artifacts.
but the higher you go, the less it'll take away. The more it'll take away for some
We tried.
things. So let's say even with that, there's still things here. You can go to your sculpt tool and go to. There's a lot of brushes here. There's bubble smooth, which means if it's something that is like, just look at the picture here. Something that is a little further down, you can smooth it so it bubbles out. And there's something that's protruding out, you can smooth it so it stays flat. And then there's robust, which just combines sort of both. So we're going to use this, the shrink smooth.
And while you're doing that, while we're running low on time, does anyone have any questions right now? While he's working? Yeah.
I noticed you have a hinge in your device at your elbow.
Yes.
And we had a prosthetist in our lab last summer, this past summer, 2 summers ago, Cheng Lu. And she marked up the recipient's form with a marker to mark, circle around the inner and outer epicondyle, and what I call the frame.
Yep.
And that's really important for where your hinge goes and how it's oriented and all of that.
So I think even on this model, we have a marker where the next prototype will actually eliminate some of the material to allow for the better articulation.
The scanning she used would show that. So that she was using the scan
Was it specific?
STL file.
Is it a specific software she was running, or is it just
Just using Meshmixer.
Meshmixer? Okay.
I'm running out of time, but let me show you something really fast that is probably really important. Oh crap, that's too big. But in order to make something that say you want to attach one of your hands onto the socket, right? You can do. Let me just finish this real quick. I know I'm running out of time. 0.15. How's that? There we go. Let's orient this.
so you can rotate it on 3 different axes.
Yeah, oh, that is the wrong hand, but that's okay.
Been there, done that.
Let's start with faces.
We at least got the hand on there.
Mirror image?
Yes, but I don't have time for that. So, if you see, there's the blue boundary, right? We're trying to connect. Let's say we're trying to connect these two things. We need one boundary and another boundary to connect those two. So, in order to create a boundary on this side here, we need to select. We need to select a relatively same size hole. And then we're going to delete it so it will create a boundary. For it to not look weird, we need to smooth that boundary out just a little bit. Delete this. See how there's a boundary now?
Yes.
So now, right now, these are two separate entities. These are two separate objects. We need to combine them into one object. Right now, click combine. So what I did was I clicked this, shift, click this. It gave me that option to combine those two. Now it's in one single object, right? So if I click out of this, it doesn't see this anymore. I click into it, sees both of this. Now I need to combine those two boundaries. Double click on this boundary and this boundary, and then I can join. This will join the two.
Whoa.
That is, it doesn't look too great, but I don't have time. But
With time and work, you can really, yeah.
it's not only is it a wrong hand, but it's sort of weird. So yes, this is how.
Yeah,
This is how you can build.
This going off the rails.
This is how you can build your own socket and your own hand, and you can print this with flexible material, and with time and care, you can create something like just like this. So there you go. And you can create this. Anything you want to attach, you can create in SOLIDWORKS, import it as an STL, and then you can connect everything together. Yeah, this is how you do it. I don't think I have time for questions.
All right, yeah.
Any
If you have
questions?
any questions, we'll be in the back and you can ask there. Thank you very much.
Thank you.
Thank you.